The moon, a celestial marvel, a silent guardian. It has captivated humanity for millennia. Since the dawn of time, we have gazed upon its silvery glow and woven myths around its ethereal beauty. Yet, for all its familiarity, the moon harbors secrets that have puzzled astronomers for centuries. Its desolate landscape, marked by ancient craters and vast plains, tells a tale of cosmic events from epochs long gone. For centuries, we have only seen one face of the moon, the familiar side that always faces us. This near side is home to the dark, flat, lunar Maria, seas, that create the patterns we call the man in the moon. But the moon's other side, the far side, remains hidden from our direct view, shrouded in mystery and intrigue. The moon's near side, the face we know so well, is characterized by the striking contrast between the dark Maria and the brighter, heavily cratered highlands. These Maria, formed by volcanic eruptions early in the moon's history, are primarily concentrated on the near side. The highlands, on the other hand, represent the moon's older, more heavily cratered crust. The far side, forever hidden from our direct view, remained a mystery until the advent of space exploration. When Soviet spacecraft first beamed back images of the far side in the late 1950s, they revealed a landscape strikingly different from the familiar face we know. Gone were the vast, dark Maria that dominate the near side. Instead, the far side was dominated by heavily cratered highlands, with only a few scattered, smaller Maria. This stark difference in terrain between the two sides of the moon has puzzled scientists for decades. Several theories attempt to explain the stark difference between the moon's two faces. One prevailing theory suggests that the near side's thinner crust, perhaps due to a massive impact early in the moon's history, allowed for easier magma flow from the lunar interior. This magma then spread out, creating the vast, smooth Maria we see today. Another theory proposes that the gravitational pull of the Earth influenced the distribution of radioactive elements within the moon's interior. The concentration of these elements on the near side could have led to increased heating and volcanic activity, resulting in the formation of the Maria. However, the mystery of the lunar dichotomy is far from solved. Scientists continue to study the moon's composition and structure to unravel the secrets behind its two faces. The story of the moon's two faces begins billions of years ago, shortly after the formation of the solar system. According to the giant impact hypothesis, the moon was formed from a cataclysmic collision between the early Earth and a Mars-sized object called Theia. This impact ejected a tremendous amount of material into orbit around the Earth. This debris, over time, coalesced under its own gravity to form the moon. Initially, the moon was a molten ball of rock, but as it cooled, a thin crust formed on its surface. The early moon was bombarded by asteroids and comets left over from the formation of the solar system. These impacts, some of them colossal in scale, left their mark on the lunar surface in the form of craters of all sizes. The energy released by these impacts also generated heat, melting the lunar surface and leading to the formation of the first magma oceans. The far side of the moon, hidden from our view for millennia, remained a tantalizing enigma until the space age. When the first images of the far side were beamed back to Earth, they revealed a landscape strikingly different from the familiar near side. The far side's crust is thicker than the near side's, making it more difficult for magma to reach the surface and erupt. This difference in crustal thickness is likely a key factor in the disparity of Maria between the two sides. The far side surface also bears witness to some of the largest impact basins in the solar system. The South Pole Aitken Basin, one of the largest known impact structures in our solar system, spans a significant portion of the far side. The far side's unique environment makes it an ideal location for sensitive astronomical observations. Shielded from Earth's radio interference, the far side offers a pristine environment for radio telescopes, potentially allowing us to peer deeper into the universe than ever before. For decades, the moon was considered a dry, barren world. However, in recent years, our understanding of the moon has undergone a paradigm shift with the discovery of water ice on its surface. The presence of water ice on the moon opens up exciting possibilities for establishing a sustainable human presence beyond Earth. The lunar poles, particularly the permanently shadowed craters at the South Pole, have emerged as prime locations for water ice deposits. These craters, untouched by sunlight for billions of years, act as natural cold traps, preserving water ice delivered by comets and asteroids over eons. The confirmation of water ice on the Moon came from several missions, including NASA's Lunar Crater Observation and Sensing Satellite, LCROSS, and India's Chandrayaan-1 mission. Water ice can be used to generate breathable oxygen, drinking water, and even rocket fuel. This makes the Moon a potential refueling station for future missions to Mars and beyond, significantly reducing the cost and complexity of deep space exploration. The discovery of water ice at the lunar poles has sparked a new era of lunar exploration, with nations and private companies alike setting their sights on these resource-rich regions. The lunar South Pole, in particular, has become a focal point for future missions due to its abundance of water ice and its potential for scientific discoveries. The permanently shadowed craters at the South Pole hold not just water ice, but also other volatile compounds, such as methane and ammonia. Extracting and utilizing lunar water ice presents significant engineering and logistical challenges. Developing the technology to extract water ice from the harsh lunar environment and convert it into usable resources will be crucial for establishing a sustainable human presence on the Moon. The presence of water ice on the Moon transforms our celestial neighbor from a barren outpost into a potential hub for space exploration. It paves the way for establishing a permanent lunar base, a stepping stone for missions to Mars and beyond. Humanity's fascination with the Moon has driven us to explore its mysteries for decades. The space race of the 20th century saw the United States and the Soviet Union vying for supremacy in space, culminating in the Apollo missions that landed the first humans on the Moon. These missions fundamentally changed our understanding of the Moon and our place in the cosmos. After the Apollo era, lunar exploration took a back seat for several decades. However, in recent years, there has been a resurgence of interest in the Moon, driven by the discovery of water ice and the potential for establishing a lunar base. China has emerged as a major player in lunar exploration, with its Chang'e mission successfully landing rovers on the Moon and returning lunar samples to Earth. NASA's Artemis program aims to land the first woman and the next man on the Moon by 2025, paving the way for a sustainable lunar presence. The Moon, once considered the ultimate destination in space exploration, has evolved into a stepping stone for humanity's journey into the cosmos. Its proximity to Earth, coupled with its resource potential, makes it an ideal location for testing technologies and developing strategies for deep space missions. By learning to live and work on the Moon, we can gain invaluable experience and knowledge that will be crucial for venturing further into our solar system. The Moon offers a unique environment for developing and testing technologies that will be essential for future missions to Mars and beyond. From advanced life support systems to in-situ resource utilization techniques, the Moon provides a proving ground for the next generation of space exploration technologies. Establishing a permanent lunar base would create opportunities for international collaboration, scientific discovery, and economic growth. It would also inspire future generations to pursue careers in STEM fields, ensuring that humanity's quest for knowledge and exploration continues for generations to come. The Moon, our closest celestial neighbor, holds a unique place in our collective imagination and scientific endeavors. Its serene beauty, visible even from light-polluted cities, reminds us of the vastness of the cosmos and the mysteries it holds. As we continue to explore the Moon's surface and delve into its ancient secrets, we gain a deeper understanding not only of our celestial companion, but also of our own planet and the history of the solar system. The Moon's desolate landscape, marked by ancient craters and vast plains, serves as a testament to the dynamic forces that shaped our solar system. By studying the Moon's geology, we gain insights into the processes that led to the formation of planets, the bombardment phase that characterized the early solar system, and the evolution of planetary bodies over billions of years. The Moon's airless environment also provides a unique opportunity to study the effects of space weathering and the impact of cosmic radiation. As we venture further into the cosmos, the Moon will continue to play a crucial role in our journey. By unraveling the Moon's mysteries, we unlock not only the secrets of our celestial companion, but also a deeper understanding of our place in the grand tapestry of the universe.